Hey, my fans, salute all of you. How na day? So I don't come again. No, one run this particular one under thermochemistry. If you be like say this name too big for you, make we use another one. Get one called heat energy. So heat energy. Now you go see this question. Under the heat energy, you see maybe subtopic we will say heat change during phase change. Heat change during phase. Phase what they talk about na PHESE during phase change. Or you will feel same as heat, maybe heat uh, in melting ice, heat in melting ice, heat when they carry melt ice. Like if you carry ice block, keep for here now. For this normal temperature, we just there like this room temperature. Ice, like ice block will just begin to melt. That heat wey dey for that environment, na im dey cause am make it melt. You know, add more heat to, not just the heat wey dey. So wetin be this question wey dey talk about? They say how much heat? They ask make you calculate the quantity of heat wey you go need to melt 100 gram. I dey analyze the question make you know what you want to do. Wey go need to melt 100 gram of ice. So if you weigh the ice now, na 100 gram e be at 0 degree. So in fact the degree of the temperature na just the way e dey. You no need to add more temperature before you go carry melt am. Na wetin dey try things. So they can't give you latent heat of fusion of for ice is 334 joule per gram. Remember, I don't give you mass. I don't give you mass because of this ground where you see here. Temperature na 0 degrees. So you no get wahala. Wetin be this latent heat? A lot of another year of latent heat, but you need to understand latent heat. Latent heat of fusion, particularly, if they talk about the energy required, the energy where you need to carry melt ice to wetin, or to carry change ice to water. Ice, what I mean, an ice block. You know, ice block now. The energy where you need, the energy required to change ice to water without changing temperature. That's temperature, no go change am, you go just dey the way e dey. So the energy we need or wey e require to carry change ice to water without changing temperature, na wetin they call latent heat of fusion. Now I don explain the necessary parameter. How I wan take solve am? Firstly, bring out the parameter. I tell you now for physics, I teach you how you go take this one physics. You go bring out parameter wey don give you. You see say don give you mass. Mass, they say na wetin 100 gram. No change am to kilogram o, abeg, you no dey necessary. Remember say latent heat of fusion, yeah, they even give you joule per gram. So you no even need the kilogram, no change am. So they don't give you latent heat of fusion. May you use short form. Latent heat of fusion equal to 334 joule per gram. Some people say, what of temperature? They don't give you 0. What do you want use 0 degree carry do now? So remember, say when we define the latent heat of fusion, say that the energy required to change ice to water without changing temperature. So the temperature all lap the way it dey. Everything we can do. Which formula we connect this one? Quantity of heat dey. We connect these two of them. Quantity of heat, Q, write am down. Say Q means quantity of heat. And they measure am for joules, don't forget. So now mass times latent heat of fusion. That be the formula. So now Q now quantity of heat is equal to M. If you multiply two of them, they are just to lap two of them. Wetin come mean? It means say mass, it then give you as 100 gram times latent heat of fusion, they give you as 334 joule per. Why they write the unit then join so that you carry I see how this gram cancel. This gram dey for denominator, this one dey normal as numerator. So if up multiply cancel out, just like Saturday, gram times joule per gram. You see, so this one is just like over 1. So you don't carry I believe now say this one and this one cancel. And now what you mean? If it cancel, now joules go remain. So now finally Q now will be the quantity of heat, or will be the heat where they say heat we need to carry melt this 100 gram to ice to water at normal temperature where you see there. Now 100 times 334. Now just to carry the 20 lap for this one now, so you can give you 33400. That's 3,400 joules. Don't forget unit for physics, so very, very important. This thing now, this topic now, you could jam for chemistry, under what they call thermochemistry. If you see German for physics, under what they call heat energy. Then they're very, very useful. But this one I solve them under chemistry, will be thermochemistry. And I hope see this particular video now, there for to you. You learn everything, I explain everything. If it's sharp, na comment section I go take know say this one really enter belle here, understand everything well well. So drop comment. And the one wey go encourage me pass na two things. When you know say you don't like this video, and you don't share and make others to then follow you learn. Then finally, if you never subscribe now. You know say anyhow now later. Ma go find another one I go do for you. I beg you to share this one and like am. I don't come out.